Before we move on to the video, if you are looking for more LEED study material, please do not hesitate to contact me on my email and on my LinkedIn. In addition to the material, I have also developed a file in which I have put all the credit categories with their respective names, adaptations to which they apply, their description, their details, furthermore required documentations, formulas, and the standards they follow in a tabular form and color-coded. And all the important terminologies related to that credit categories are stated below. Feel free to contact me and I'll be more than happy to share all with you. Hello and welcome. When I first decided that I'm going to make a series of videos that might help people who are willing to attempt LEED AP BD+C or even LEED Green Associate credentials, I felt that there are some basic terminologies and concepts that we need to understand before we jump in onto that. So I call it a pre-LEED BD+C V4 video in which we are going to see the terminologies like GHGs, their emissions, ODP, GWP, sustainability, and even the LEED business case. So we're going to discuss a brief history of these terminologies and a little bit of their explanation. Let's start with GHG. It stands for greenhouse gas, and they are found in the atmosphere. But why are they called greenhouse gases? Obviously, it has something to do with the greenhouse. This is how a greenhouse looks like. That secures heat and water vapors to maintain humidity and warmth inside the greenhouse for the plants to grow. Now, greenhouses are found in the colder climates, and there's a significant difference in the temperature outside and inside the greenhouse. The sun rays carrying energy is trapped inside the greenhouse, and this energy is absorbed by the gases and re-radiated as heat, making the temperature inside higher and suitable for the plants. It's exactly the same way a car traps heat inside when it's parked under the sun in summers. I'm sure you have experienced that. So how does atmospheric gases resemble greenhouse gases? Now let's see how the greenhouse gases have the same effect in the atmosphere as in the greenhouse. I found this GIF on climate.nasa.gov that explains almost everything. If you look at the GIF, the sunlight reaches the earth, some energy is reflected back into the space, some is absorbed and re-radiated as heat, and most of this heat is absorbed by the greenhouse gases and reflected in all directions, in turn warming the earth. So these GHGs or greenhouse gases are important because if these gases do not act the way they do, if they do not absorb energy and radiate it as heat, then the temperature of Earth would be minus 18 degrees Celsius, which means that we will not experience the life as we do it now, or at least not the way we know it. Now we know that what are greenhouse gases, why are they called greenhouse gases, and let's see what are these gases. There are two types of greenhouse gases mainly. When I say mainly, it means that these are the ones we are talking about and these are the most significant ones. It does not mean that these are the only gases. So there are two types: naturally occurring gases, which can be like water vapors, methane, carbon dioxide, nitrous oxide. And then the second one is man-made or industrial gases like CFCs, HCFCs. And now we will see that how they end up in the atmosphere. So there are two types. One of them is natural greenhouse or atmospheric gases, which means that they are occurring naturally in the atmosphere with or without human activity. First of all, this is water vapors. You might recall from your earlier days of science class, the water cycle, which is the precipitation, formation of clouds, evaporation of oceans, coming back down as rain. That's exactly the same. When you boil water at your house, you are also releasing it into the atmosphere. And it's the water vapors act as feedback loop. The warmer the earth is, more water vapors will be found in the atmosphere and vice versa. For methane, it's being released in the atmosphere with the agricultural practices, livestock manure, dung, or excretion, whatever you want to call it, production and transport of coal, oil, and gas. And when your waste ends up in the landfill, this also produces methane and released into the atmosphere. The agricultural and industrial activities again release nitrous oxide as well. Treatment of wastewater and the cultivation of rice also produces nitrous oxide in the atmosphere. Carbon dioxide occurs again naturally as part of Earth's cycle or carbon cycle. When you exhale, you release carbon dioxide in the air. Burning of coal, oil, and gas also release carbon dioxide in the atmosphere. Deforestation is one of the causes for carbon dioxide abundance because the plants take this carbon dioxide and by the process of photosynthesis they produce oxygen. So when we cut the trees, this process does not take place and carbon dioxide is being released in the atmosphere. Man-made or industrial gases means that they end up in the atmosphere just because of human activity. They would not be there at all if they are not being produced or released in the atmosphere. So they are mainly HCFCs or CFCs used as refrigerants. They are sometimes used in other applications like fire extinguishing foam and some others. They are released during the production the production inside the facility or factory. They're released in the atmosphere by some leakage and also when you are disposing of your old equipment. Now this is a pie chart I found on EPA website, which is Environmental Protection Agency, and it shows in terms of metric tons the US has seen in 2017 in terms of greenhouse gas emissions. If you see the biggest chunk or the biggest part is being released in the atmosphere, that is carbon dioxide 82%, methane 10, nitrous 6, and other gases, fluorinated gases at 3%. Now we know what are the natural gases inside the atmosphere, what are the man-made. So we want to know that how do they affect the climate and which gas is most harmful, what are the reasons behind. So in order to determine this, there are three major factors. Abundance or concentration in terms of parts per million, parts per billion, sometimes parts per trillion, their age in the atmosphere, how long they can stay in the atmosphere without decomposing, and their impact on the atmosphere, which is checked by their ODP and GWP. We're going to see now what does it stand for and how does it affect the climate. So ODP stands for ozone depletion potential, which by definition is ratio of global loss of ozone due to the given substance to the global loss of ozone due to CFC11 of the same mass. CFC11 is a man-made gas and it has been benchmarked as one of ozone depletion potential, and other gases are compared that how much loss they make or they produce to the ozone. We know that ozone is the layer in the stratosphere and it helps us from the harmful rays of sun coming down to the earth. You have also heard about some other names of CFC11 like trichlorofluoromethane, CCl3F, and Freon, which is the most common name. I'm sure you have heard about it. And this is the diagram that I have found that explains how CFCs are being released, how they act with the ozone layer, and how it creates a hole, and then the harmful rays are able to come down to earth. Because of this damaging property, CFCs or the chlorofluorocarbons, which are man-made gases, were banned from production under Montreal Protocol with a phase-out plan more than 2 decades ago. You can search what Montreal Protocol is. It's an agreement based on which you have to, the CFC production was banned. Then for the intermittent time, they were replaced by HCFCs, which are hydrochlorofluorocarbons, and they had lower ODP compared to CFCs. But again, there was ozone depletion potential of these gases, and this was not acceptable. So they are then phased out and they were replaced by HFCs called hydrofluorocarbons. They had ozone depletion potential of zero. So we had solved one problem. We had two factors, ODP and GWP. So we came to a point where we had this man-made gas that has now zero ODP. But HFCs has to be phased out again by 2020 for GWP. So we somehow catered ODP, but GWP is still our problem, and we're going to see how. Uh, Under amended Montreal Protocol, and they are to be replaced by natural refrigerants like ammonia and nitrogen compounds, etc. In terms of damage, ODP was more important, and based on Montreal Protocol, we have seen that we have banned and phased out these gases. So GWP stands for global warming potential, and as per the definition, it's the heat a gas traps in the atmosphere up to a specific time compared to CO2. Just as we saw CFC11 was benchmarked there, here benchmark gas is carbon dioxide whose GWP of 1. Now carbon dioxide can stay in the atmosphere for hundreds of years, but the good thing is that it has an ODP of 0. Now, based on the pie chart we have seen earlier, for the carbon dioxide part of 82%, it can further uh, can be broken down to the transportation part is responsible for 34% of release of carbon dioxide, electricity 33%, industry 15%, and the rest of it. So it means that 82% of carbon dioxide can be broken down to this pie chart, and this is taken from the same EPA website for the same year of 2017. This is a disturbing graph that we can see here. The abundance of carbon dioxide. We know that abundance is the major factor that affect the climate. So we went somewhere from 330 parts per million in the late 70s to 410 or more parts per million in 2020. What happened was that it created a global outcry, and the CO2 mitigation strategies became inevitable. You have to reduce the usage by all means possible. You have to reduce fossil fuel usage. You have to reduce usage of electricity that is being produced by fossil fuel use. So whatever you could do, for example, you could eliminate carbon dioxide emissions from atmosphere by forestation. So this forestation also should take place, and all this carbon dioxide emissions and outcry led birth to the term called carbon footprint. Carbon footprint, by definition, is total amount of greenhouse gases, mainly CO2, produced directly and indirectly by human activities, usually expressed in equivalent tons of CO2. Even if you release some other gas, the GWP of that gas compared to CO2 would be considered, and it will be released in terms of carbon dioxide emissions. So it will always be carbon footprint, even if you release some other gases in the atmosphere. Now you might have seen something called carbon footprint as in the visual form, that how much fuel you are using because it releases carbon dioxide in the atmosphere, how much waste and how much gas, how much electricity you are using. So everything is now boiled down to the carbon emissions. It will be recorded, it will be projected in terms of carbon. Same is the situation with the buildings, that the material you purchase for building production, they release carbon dioxide in the atmosphere from the factory. Then during the construction, all these activities releasing carbon dioxide in the atmosphere, and when the building is there already operational, then it releases the carbon dioxide in the atmosphere in terms that it uses electricity, or it might use the space heating, which needs burning of coal, oil, and gas. Then it gave birth to other carbon-related terminologies like carbon neutral, net zero carbon, carbon offsets, embodied carbon, operational carbon, and a lot more. In response to all this carbon terminology, there were even more confusing things that coming along your way, like green, sustainable, eco-friendly, clean, organic, non-toxic, fair trade, ethical. But since we are talking about buildings, two are more popular. It's green and sustainable. The terminology of green and sustainable are used interchangeably, but there is a slight difference. If you see green, it helps reduce the footprint it leaves on the natural environment and on the health of its inhabitants. It deals with the present sort of situation, whereas in sustainability, it creates and maintains the conditions under which humans and nature can coexist in harmony, permits fulfilling the social, economic, and other requirements of present and future generations. This is the key part that it takes also into consideration the future part. We will see in a small example that sustainability is kind of bigger than green, or you can say that green is a subset of sustainability. We can see it from the example that things or product can be green but not sustainable. If you see a bamboo floor that is being produced from renewable source, or if you see an electrical vehicle, they both are green in nature. In terms of use, they both are green. But transport pollution disqualifies them from being sustainable. If they are transport from one place to another using the ships that are burning the fossil fuel, that is releasing so much carbon dioxide in the atmosphere, so it kills the idea of sustainability, because you are using too much, you are releasing too much carbon dioxide in the atmosphere only in transferring a green product. So sustainable, it will be if it is harvested, produced, transported in a green or responsible manner. So it's like a life cycle of this product should be green, and not only the product itself. So green plus sustainability, I try to coin a term, is called greenability. That's kind of taking care of both. There is something interesting I found, that green is a trend these days, but sustainability is the mindset where you have to think of the future generations to come. Now, what does LEED do? We know that LEED stands for Leadership in Energy and Environmental Design, and we are talking about building design plus construction. It involves a pre-design process to save energy and water. So if you're saving on energy, you're saving on the carbon dioxide emissions that are being released in the atmosphere, and it helps the goals of green and sustainability. It helps you in the, or guides you in the selection of site, type of site, location of site, and some other stuff. LEED focuses on building material selections. We just discussed that it guides you in the selection of material that is being harvested, produced, and transported in a green or responsible manner. During the construction, LEED guides you about waste reduction using modular construction and some other methods. It asks you to make pollution prevention or a plan for it. It also guides you for the well-being of the building occupants by having a standard of air quality and quality views and some other requirements. It encourages to use alternative fuels, which could be wind energy, it could be photovoltaic cell energy, and if you use alternative energy, it means that you are reducing the usage of fossil fuel electricity, and you are reducing in turn the carbon dioxide emissions in the atmosphere. It also caters about the demolition and reuse of the building. So it's safe to say that LEED deals with the whole life cycle of the building, from the conception or from the pre-design process to the demolition or the reuse of the building. Let's have a look at this table. It says that the buildings usage in the United States. When I say buildings, it consists of all buildings, like all healthcare facilities, household, offices, residential, whatever kind of buildings they are. As per EPA, it says that the 40% of total energy use but total energy produced in the United States is used by the buildings. 12 to 14% of total water consumption, 38% of contribution to the CO2 emissions is done by buildings, and 30% of total waste produced in the United States, or the waste output, is by buildings. So this is the LEED business case. If you go for the options or for the recommendations, or what is defined by LEED or in their rating system, you can reduce energy use by 26 to 30%, water use by 30 to 50%, carbon emissions by 35%, reduce waste output by 50 to 90, and increase occupant satisfaction, this is kind of subjective, but by 27%, and lower maintenance cost by 13%. There are some people who argue that the global climate change, the carbon emissions, and all that things are a bit overstretched, and they are not as what we are told. But with all due respect to all those people, without going into the debate, my point is that if you are coming with a technology, if you are coming with ways to reduce waste, to reduce any emissions, and to use your sources more efficiently, then why not? So the business case for LEED stands. And by all what we have said and what we have learned, what LEED focuses on, what LEED tries to guide on, and with this table, I think it is safe to say that LEED focuses on greenability. For more information on these topics, from where I got all this information from, you can go to NASA official website, you can go to EPA official website, and there is a lot more information there for you to learn. There is a fun fact that Bhutan is the only country in the world that is carbon negative. This is for you to search, and this is all for this video, and we will continue to the introduction.